Anyways, yeah, today let's see like how many of you will clear the first round, and later we'll see what happens. Today we'll start with the areas and volumes. So, so it's a like very simple and maybe I can say a dry concept. It is not as complicated as calculus or trigonometry. So here, all that you need to do is observation, and once you observe the question, you will get the answers very easily. And all that you need to know is couple of very simple formulas. Like in 10th standard, you might have to maybe some formulas you might have to by heart them, but we will be trying to derive as many formulas possible. uh, in some cases, like we might need integration, which you will learn in first pu. We will ignore those derivations. Okay. Before actually going to areas, let's see a couple of problems on the perimeters. Okay, we'll directly jump to the problems today. So this is our first problem for the day. If the star has an outside perimeter of 50 and the pentagon has a perimeter of 30, what is AB plus BC plus CD plus DE plus EA? So this is a very simple problem. Try to answer. Put your answers in the chat, or you can unmute yourself and tell the answers also. Okay, I'm getting the answers. Check the question properly. If the star has an outside perimeter 50 and the pentagon has a perimeter of 30, what is the value of AB plus BC plus CD plus DE plus EA? So those who have not turned on the videos, I'll be asking you the answers. Okay. Now I can see many of you turning on the video. Okay, come on guys, turn on your videos. So if I see anyone turning off the video, I'll be asking you questions. Okay, let's see what are the answers. Okay, most of you are saying 80 as the answer. What do you think, guys? Is 80? 80 is the answer. Okay, so most of you are saying 8 is the answer. This is a very simple question. Let's see why 80 is the correct answer. See, we have a star. We have a pentagon and has a perimeter of 30. So we have a pentagon with the perimeter of 30. So this pentagon is 30, and the outside star. So this outside star, whatever this outside star we have, is 50. All that we want is this plus this plus this plus this plus this. So if I trace this, it is nothing but sum of this and sum of this, correct? If I cover individually, it will cover the entire star. So the entire perimeter is just 30 plus 50, which is 80. Okay, this is a very simple problem. We are just warming up. So as and when we progress, we will see some interesting problem. So any doubts in this problem? Anyone has doubt in this problem? Pranam MG, do you have any doubt? Can you speak up, Pranam MG? Can you speak up?
Yes, sir.
Okay, do you have doubt?
No, sir.
Okay, we'll move on to the next problem. Just go to the I'll go through the problem. The centers of the circle and a corner of the square are all at the same point. The square side length is 10 meter. What is the area of the shaded part of the diagram? These questions you might have seen, some of you might have seen already in 9th standard. So those who haven't attended 9th standard foundation, try to answer this. Okay, can anyone try answering this? Can you speak up?
Sir, if we rearrange the shaded portions, then we can complete the right triangle.
Yes, very good. So what he's saying is, if we rearrange, for example, we have this portion, this small portion and this small portion, they have equal areas, right? So what I'll do is I'll shade this part. Okay, so I am shading this part, and I'll ignore this part. Okay, for now I'll ignore this part because I have covered it in on the left side. Similarly, I'll ignore this part and I'll shade this part, which is same as like copying the right part to the left part. Now, if you see this, now if you see here, you have a triangle. You have this triangle, and all that we need is area of this triangle. And what is the area of that triangle? Half into 10 into 10, because area of the triangle is half into base into height, 10 into 10, which is 50. Okay, this is also a very simple problem. Just that we had to do is we had to rearrange the areas. Okay. Any doubts here? Anyone? Okay. We'll move on to next question. Which figure has the largest shaded area? Which figure has the largest shaded area? What's the answer? Seem to be equal. Why? Why do you think it's equal? Can you explain?
Like the circle is divided into pieces and arranged in the other.
Yeah. So what he's saying is, in the first case, a big circle is divided into 4 equal parts and they are arranged, correct? So basically we have divided into 4 equal part and then we flipped it and we have arranged it. Similarly here also we have taken the same circle and we have rearranged it. So all the these blue shaded areas have equal area. So all the 3 circles, all the 3 figures have equal areas. Okay. We'll move on to the next question. Yeah. Try this question. 3 semicircles with equal radii are drawn inside the large semicircle so that their diameters all sit on the diameter of a large semicircle. What is the ratio of the red area to the blue area? Which one will have more area, blue or red? So obviously blue will have more area. So ratio should be like a fractional ratio. So the answers are 1 by 2 and 1 by 3 we are getting. Any other answers, students? Muralidhar, can you explain why is it 1 by 2?
Sir, I took without loss of generality that the diameter of the bigger circle is 3. So the diameter of the smaller circles will be 1, 1, 1.
Okay, this is you are taking as 3, and this if you divide it into 3 equal part, radius of the smaller circle will be 1. Then
Yeah, then we just apply the area formula. Pi r square divided by, we should take the area of the bigger circle and then subtract it with the area of the 3 red circles, and the quotient will be our answer.
yeah, so let's do that. What he's trying to say, instead of taking 3, we'll take it as r. Okay. uh, we'll go with our traditional method itself. So we take this as, say, r. Okay, radius of the bigger circle as r. Okay, so we can take radius of smaller circle, this radius to be r by 3. So what is the red area? Red area is nothing but 3 times pi times radius is r by 3 whole square, correct? R by 3 whole square. Okay, so and what is the entire area? Entire area is okay, so this I have to divide by 2, correct, because all of them are semicircles, correct? So entire area is pi r square by 2. How much is this? The red area, pi r square by, is it pi r
6.
square by Yeah, pi r square by 6, because here we have in the denominator we have 3 square, which will become 9. 3 ones are 3 threes are, then we have 2 here, so it will become 6. Pi r square by 6. So what will be my blue area? Blue area will be pi r square by 2 minus pi r square by 6. How much is this? 2 pi r square by 6. So what they asked? They asked area of red to blue. So red to blue is pi r square by 6, and this is we have 2 pi r square by 6. So ratio will be 1 is to 2. I think those who are told 1 is to 3, what you guys have done is you have taken this area and you took the ratio with the entire area, I guess. Yeah, so Muralidhar is also trying the same, telling the same thing. They are getting 1 by 3 because they forgot to subtract. I think these kind of mistakes we do most of the time whenever there is a simple problem. So you have to be careful, especially in NTS anyway, that is over now. Same thing will happen in JEE mains also. Okay, JEE advanced they will not ask such stupid questions. In JEE mains sometimes they will ask such stupid questions, and you will end up making mistakes. Similarly in NEET also, in physics especially, they will ask such questions where they're just playing with the options, not they're not checking your knowledge there. So you have to be careful while attempting such easier problems. Okay, we'll move on to next question. Again, this is also, give me 1 second. Yeah, again, this is also a very simple question. Let's see what do we have. A square is inscribed in a circle, and a circle is inscribed in that square. What will be the ratio of the area of the bigger circle to that of the smaller circle? Okay, how do we start this? Uh, how can we start this? Like in the previous question, like we took radius of the bigger circle to be r, and then we took radius of smaller. We got the radius of smaller circle, which is r by 3. Correct? That is what we had done. In this question, what can we do?
Smaller as R and bigger as root 2R.
Okay, so we will start with the smaller circle. Okay, yeah, fine. Then we'll start with the smaller circle. So this is we'll take as r. If we take this as r, all that I need to know is what is this one. Okay, I need to figure the bigger radius. How do I get the bigger radius?
Pythagoras.
Pythagoras theorem. Where should I apply Pythagoras theorem?
But that's it is a square, so it's R is half of the side.
Yeah, so if you see here, we have a square here. We have A, B, C, D is a square.
CB is R.
CB and AB is R, because even the CD is R. Because the CD is R because it is a radius of the smaller circle. So automatically even this will be R, AD will be R. Now I apply Pythagoras theorem like this. Correct?
That's good.
Yeah. Now if you apply Pythagoras theorem, you will get AC as square root of AB square plus BC square. AB and BC are same, so it is R square plus R square, square root of 2R square. So it is nothing but square root of 2 times R. I'll call this as bigger R. Okay, they have asked again ratio of the bigger circle to that of smaller circle. So we will have pi r square divided by pi r square. Okay, let's call this bigger one as r. Okay, so this will be pi times 2r square divided by pi r square. So this implies 2 is to 1. Any doubts here, students? Any doubt? Okay. Now try answering this question. What fraction of the rectangle's area is taken up by the regular hexagon? What fraction of the rectangle's area is taken up by the regular hexagon? Yeah, everyone is saying 3 to 4. Why is it 3 to 4? Can anyone answer? Why is this 3 to 4? Should I name the triangle, name the vertices again? I'll name it for you. Say this is A, so this is A, B, C, D, E, F, G, H, I, J. How to get an area of a regular hexagon?
So we can break it up into 6 equilateral triangles.
Yes.
So then we can apply area formula of equilateral triangle and into 6.
Yes. So I'll take the center. Before that, I'll erase this. So I'll have 6 equilateral triangles. Okay, now I have 6 equilateral triangles. Can you again tell me why they are equilateral triangles? Why they are equilateral triangles? Yeah, why they are equilateral triangles? Ricky.
I'm thinking, sir.
Okay.
Sir, can I?
Yes, Varun.
Because we divided the central angle 360 into 6 parts.
Yes.
So each part is 60 degrees.
Each part is 60 degree. That is why? Because they are regular. It's a regular hexagon. Okay.
Yeah. Now,
Yes. Then
from the center, EO and FO are equal.
EO,
मतलब, just,
FO are equal.
so like both the angles are going to be 60 degrees, right?
Yeah. So both the angles have to be 60 degree. So this proves that it's the what is it? Equilateral triangle. So once we get that it's an equilateral triangle and say this is R. So what will be the total area of this blue thingy? It will be 6 times area of hexagon will be 6 times. What is the area of equilateral triangle? Root 3 by 4 R square or 3 root 3 by 2 R square. What next? If you know this is R, if you know that this is R, can you tell me what is this and this? What is this angle?
Sir, excuse me, sir.
Yes,
How is EO equal to FO, like apart from visual interpretation?
it is a regular hexagon, right?
Okay, so the distance from the center to the vertex.
Yes, it is same.
Okay, sir.
We can find the ratio between the sides you mentioned, that is JF and JE by trigonometry, because one angle will be 60 degree right there. JEF will be 60°.
Yeah. First of all, even this is 60°. So automatically, even this will be 60. And anyways, it's given that is a rectangle. So this angle will be 90°. So this will be 30°. Correct. Now, can you tell me what is JF in terms of R? Can you tell me what is JF in terms of R?
√3r/2.
Yeah, so everyone I think knows some at least the basic things in trigonometry. So we have sine 60. I'm using this angle. I'm using this angle for this triangle. So sine 60 equal to JF by hypotenuse, which is R. How much is sine 60? √3 by 2. So which is same as √3 by 2. So what will be my JF? R into √3 by 2. Similarly, can you tell me what is JE? Now I'll apply again. I'll apply sine, but I'll apply sine on this angle, this angle F. So sine, now I have to put sine 30. Sine 30 is again opposite by hypotenuse. Now my opposite is JE and hypotenuse is R. This is my hypotenuse. Okay. So with again sine 30 is half. This implies JE equal to R by 2. So what is the area of this triangle? I know JE, I know JF. I can get the area of the triangle, correct? Any doubts here till now, students? Medha? Is it clear? Okay. So area of triangle JFE, triangle JFE is half into R by 2 into √3 by 2R, which is nothing but √3 by 8 R square. We have 4 of those triangles, correct? We have 4 of these triangles. So this entire area I have to multiply by 4. I have to multiply by 4. So I'll get √3 by 2 R square. Now area of hexagon is 3 times √3 by 2 R square. Here it is 1 times √3 by 2 R square. So area of hexagon to that of the rest of the area is 3:1. Okay, is this clear? How is JE R by 2? Why J is R by 2? Because now if you take this triangle, this is a right angle triangle with this angle F being 30°. Okay, so I can zoom it out. If you take this triangle, this angle is 30°. I'll apply sine 30 here. Sine 30 is nothing but opposite side divided by hypotenuse. Okay, so now I'm applying sine here. So this is what I have done. Sine 30 is nothing but JE by R, and sine 30 is half. We know the trigonometric value of sine 30 is half. So we will get J equal to R by 2. Okay, yeah, the question is not complete. They have asked what fraction of the area of the rectangle's area is taken up by the regular hexagon. So till now what we found is ratio of hexagon to that of these 4 smaller triangles. But that is 3:1. They are asking this what fraction of this area is covered by hexagon. So that will be 3/4. Okay, that will be 3/4. Why? Because you have 3 parts of area which is hexagon and 1 part of area which is the smaller triangles. So totally there are 4 parts, out of which 3 part is hexagon. So it is 3/4. Yeah, 3/4 is the answer. Okay, this one looks an interesting problem. Try answering this. A triangle, a square, a pentagon, a hexagon, and an octagon, and a circle all have the same perimeter. Which one has the smallest area? We'll go back to the previous problem once. So there is one observation made. So whatever observation we made was so someone assumed that this is a square, correct? So let's see whether it is a square or not. Muralidhar is saying it cannot be a square now because this length I know, this length I know, correct? This is nothing but root 3 by 2r, root 3 by 2r. So this entire length is root 3 times r, correct? So this entire length is root 3 times r. Jg will be root 3 times r. Similarly, we know this length, we know this length, we know this length. So this is r by 2, this is r by 2, this is r. So total length will be 2r. So it is not a square. Yes. Very good observation, Muralidhar. So he is saying we cannot inscribe. Inscribing means we cannot put a regular hexagon inside a square. So Muralidhar is saying, so from this question, we can say that we cannot inscribe a regular hexagon inside a square. Is that true all the time? Can you think about it and let me know in the next class? Like, do we need to have ratios in the ratios of the this rectangle in root 3 to 2? That is root 3 to 2 as a ratio to inscribe a square, a regular hexagon in a rectangle. Okay, or can we inscribe it in a general square, or can we inscribe it in any other rectangle, maybe say 2 is to 4, 3 is to 5. So say if the ratio is say 3 is to 5, can we inscribe a regular hexagon? This is your homework and let me know if it's possible or not. Okay, yeah, we'll go to this question now. Okay, so we'll continue the problem. So what's the answer? Did you try, students? It should be triangle or circle. Okay, you ignore about the rest of the things. Okay, if it's the fight between triangle and circle, like which one will have smallest area? Just take take P as the perimeter for the triangle and P as the perimeter for the circle, and try to get what is the side length here in the case of triangle and what is the radius in the case of circle, and check what is the area for the triangle and area for the circle. Then we'll worry about the rest of the things. Okay, if P is the perimeter of this equilateral triangle, what is the side length? What is the side length? P by 3. Yeah. So side length will be P by 3. Side length will be P by 3. So what is the area of an equilateral triangle with side length P by 3? What is the formula for the area of an equilateral triangle? Root 3 by 4 a square. Root 3 by 4 a square is P square by 9. P square by 36 or P square by 12 root 3. Now, what is the radius in case of circle? What is the radius in case of circle? So if P is the perimeter, 2 pi r is P, correct? Perimeter is 2 pi r. So we will get r to be P by 2 pi. So what will be my area? Pi r square, which is nothing but pi into P square by 4 pi square, which is same as P square by 2 pi. How much is approximately 2 pi? 2 into 3.14. So this is also same as P square by 6.28. So area of the circle is P square by 6.28. And here, how much is this approximately? Yeah. So as he is suggesting, we'll make this as P square by 12 root 3. 12 into root 3 is obviously a bigger number compared to 6.28, correct? So this is a bigger number. That means this fraction is smaller compared to this fraction. If I compare these two, triangle has the smallest area. Okay. So note it down. So if the perimeters are same for a triangle and a circle, triangle will have the smallest area. Now shall we compare it with the square? We'll compare it with the square now. So I'll erase this circle part. I hope this is not needed for you guys. So I'll erase this part. So let it be like this. I'll still write it down here. So this will be P square by 2 pi. For the circle, area will be P square by 2 pi. For square, side length will be P by 4. Correct? For a square, side length will be P by 4 because the entire perimeter is P. So side length will be P by 4. So for the square, area will be P square by 16. So here we have P square by 16 for the square, and here we have P square by 12 root 3. Between 12 root 3 and 16, which one is bigger? 12 root 3, because 12 root 3 is 12 into 1.7, which is approximately 20.4. So this is 20.4 and this is 16. So again, P square by 12 root 3 is smaller. So similarly, if you can check for maybe hexagon, because we already know what is the formula for the hexagon. So if say this, we'll check for hexagon now. I'll erase this part. Now side length of the hexagon will be S is equal to P by 6. Correct? Because all the sides are equal. What will be area of the hexagon with radius R? Okay, so what is the, we'll look at the hexagon now. So for hexagon, we have P as the perimeter. We have P as the perimeter. So side length will be P by 6. So what is the area of an hexagon with radius R? So what is the area of an hexagon with radius R? We had seen this. Root 3 by 2 R square. Correct? So area will be 3 root 3 by 2 R square. But what is R in our case? P by 6. R in our case is P by 6. So it will be 3 root 3 by 2. R is P by 6, which will be P square by 36. So if I simplify this, what do I get? Yeah. So 3 root 3 by 36, we have P square, we have 2 into 4 root 3. P square by, is it correct? P square by 8 root 3? 3 ones are 3, 12s are, we have 3, 4s are, yeah. P square by 8 root 3. Now if you compare it with this one, that of triangle, P square by 8 root is bigger. So we have triangle as the smallest one. So now we have seen triangle, square, hexagon, and the circle. And if you can see from here to here, and from here to here, and from here to here, the area has increased. Okay, the area increases as we increase the number of sides. You can say that this circle is a regular polygon with infinite side. Correct? No? So we can generalize like this. So area increases this way. Now those who are interested in finding area of a pentagon, and this octagon, you can apply trigonometry. Okay, you can apply trigonometry and you can get the area. Try this tomorrow and let me know. If you don't get it, I'll prove this in next class.
Excuse me, sir.
Yes, Muralidhar.
Actually, if we assume that all of them have the same height, that is from, you understand, right? Right? If they have the same height, then we can easily prove that square has the greatest area.
If you assume that they have same height,
Height in the sense, how to tell?
this height you're saying,
Yeah,
then even this circle will have that height, right?
yeah.
Then
So
circle will have the greatest area, right?
no, not just the height. It's like if everything have the same height, then if you see, okay, first we'll take the pentagon. For the pentagon, we can add some triangles and complete it into a square.
Like this you're saying.
Yeah.
Okay.
You can do similarly for all the other figures.
That is provided this height of the pentagon is same.
Yeah, that is more. Yeah, the height should be equal. And the reason you can do that is the side measure from the square, it progressively decreases. So you can always fit in a triangle so that the side measure will be equal.
Yeah.
And since you're adding triangles, you're adding some extra area. So initially they had less area than the square.
But the problem here is the moment you try to keep the height same, this pentagon will go outside the square. Then how will you compare it?
No, it cannot go outside the square. See, you have to add some triangles. The only why you can add the triangles is because the lower base of the pentagon is there, that is smaller than the side of the square.
Then we cannot have the height to be same.
Yeah, but the height is not directly related to the sides, right? There will be some factor.
Height is related to the sides as it is a regular one, right?
Yeah, but there will be some factor that will make it up for that.
See, if you're taking, see, either you can consider the perimeter thing. So if you're ignoring the perimeter fact and you're considering only the height factor, okay, then this side length may increase by a little. He wants this and this to be same. That cannot happen.
No, not that. I mean, just the heights of all the figures should be.
If you want this height to be same, then we cannot have this to be same. This will increase by a little for each and every figure.
No, we can directly assume that the heights are equal, right? It's almost obvious. At least the ways in which the figure is drawn.
Okay, what you can do is, do you know how to use GeoGebra?
Yes.
Okay, can you try drawing all these figures in GeoGebra with the same height? You can place one by one, and then try to move everything like within this triangle, and let me know if all these figures will fit inside this square.
Okay, they may not fit inside, exactly inside. Some part may go out.
Yes.
Yeah, but it will be compensated with the one those are inside. That is because you can always add triangles to any of these figures on their exterior to complete the square.
Still, see, what I'm saying is the moment something goes outside, okay, like this, okay, there might be a case, whatever this smaller area you have here outside, this will increase, may increase drastically in such a way that area of that regular polygon will be more than this regular square.
No, I'm not meaning that. Take the pentagon and draw some triangles so that it will at least look similar to the square.
So all that the factor you're considering the height factor.
Yeah, if the height is equal, then the square, then what you will construct, that will be equal to the square, right?
Still, see, it might be equal, but still I have some confusion because
Heights are equal, which should be equal.
if the heights are equal, width need
Should
not
be.
be. Need not be, right?
It's inside a square.
Uh, no, but see, so do one thing.
Yeah,
Tomorrow,
I
tell
will do
me
in
that,
GeoGebra.
that is one part. Tomorrow, tell me what is the relationship between height of a pentagon to that of the side.
Okay.
If you give me that ratio, then we can say whether the pentagon will fit inside or outside or what happens to the area. Okay, that's the best thing we can do, right? Yeah. So tell me, like, what is the relationship between this and this? Everyone, try that at home, and I think we can answer this question tomorrow. But
Sir,
in this question, like, we have perimeters to be same. So I'm not sure where exactly we can put the height analogy in this question. That is a separate question which Muralidhar asked. Okay.
Okay, sir.
Yeah, and also one more task you have is try to get the formula for area of this and this. This one is like pretty simple. All that you need to know is tan 22.5 that you can get by tan 45, tan 2a formula. This is a bit tricky. I think you will end up with the 37 degree or something. Just check it and apply Pythagoras theorem. Yeah. One more question on finding the areas, shaded areas. Can you try this? What fraction of this large square has been shaded red? Pramata is saying 1 by 4. It should be more than 1 by 4, right? So if I have a square like this, and if I shade this red, this will be 1 by 4. But here we have this extra, this extra, this extra, this extra. So it is not 1 by 4. Ketan is saying 2 by 3. Red has occupied 2 by 3. You think red area is more than blue area? Okay, he's saying 1 by 3. Yeah, one obvious thing is like red area is less than blue area. That is, we can see it clearly. And one more obvious thing is it is not 1 by 4. Correct? Those 2 points we have to be like seeing it properly. Varun is saying 1 by 2. Why is it 1 by 2, Varun? Or why is it 1 by 3? Ketan.
sir, I took the side as 2A.
You took the side as 2a.
Yeah. So that red,
Yes.
the first red one has A as its side.
Yeah. So this will be a square. Fine.
Yeah. Then it's an infinite GP, right?
Yeah. So this what will be the area? What will be the side length?
Side length A by 2.
Yeah. So this side length will be a by 2 because this is a. So this will be a by 2. So area here will be a square by 4. Then we will have,
A square by 16.
yeah. So this area will be a square by 16. This will be a square by
64. 64.
is it 5 square or is it 32 or 64? I wanted to write 32, but it is not 32. See, from
64.
8, it is 64. Yeah, because uh, we are reducing the length by half and area will be reducing by 4, like every time. So what do we get? So we have a square plus a square by 4 plus a square by 16 dot 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 for infinite terms. So this is a GP with the common ratio 1 by 4, correct? So what is the sum in case of a GP? What is the sum in case of a GP? Formula, geometric progression is done for you. A divided by 1 minus R, where A is the first term. A divided by 1 minus R, where A is the first term. So first term in our case is A square, and common ratio, as we discussed, it is 1 by 4, because if you see from here to here, it decreased by 1 by 4. Here to here is 1 by 4, here to here is 1 by 4. So we have 1 minus 1 by 4, which is nothing but 4 by 3 A square. So red area is 4 by 3 A square. The entire area, will be big area. How much is big area?
4A square.
4A square. Okay. Now, what fraction of the total area has been shaded red? Yeah. So red by big area. This will be 4 by 3A square by 4A square, which is equal to 1 by 3. So is this clear? Okay. Suppose we don't know GP. How do we do? Okay. If we don't know GP, how do we do? So take a look at here. You have this red area, and suppose these two, I'll shade these two areas with the purple color. Okay. What happens next? Next, if you go to this bottommost square, again I can do the same thing, because all that I'm interested in this is the red area. So here also I can shade this red, and I can ignore, I can color this purple with the blue. And if we continue like that, it will keep on happening like that. For every red area, I'll get 2 purple areas, correct? So out of 3 areas, 1 will be red. Similarly, out of 3 areas, 1 will be red. Out of 3 areas, one will be red. Out of 3 areas, 1 will be red. It will keep on continuing. So eventually we will reach this end point. So out of 3 area, 1 will be red. This is how you can imagine, and you can try to answer if you don't know about geometric progression. Yes. So we'll go to the next problem. What is the surface area of pyramid? Okay, now we are coming to the actual surface areas. Like till now, whatever you have learned, I think this was done in 9th standard, like rearranging the areas, calculating area per square, those things and all. Now we'll see some actual figures, maybe pyramid, hemisphere, sphere. I think these are there in your 10th standard syllabus also, as far as I know. Okay. We'll start with the pyramid, then we'll try to see a couple of formulas, and then we'll try to solve some more problems. Okay. So try to get an answer for this question. What is the surface area of this pyramid? Okay, everyone is saying 64. Why is it 64? First of all, we have a square base. So if you draw this, complete this pyramid, we have a square base like this, and then we have 4 triangles. Yeah. So the surface area will be square base plus 4 times triangle area. Correct. Square base area will be, we know that this is a 4 centimeters. So we will get 16 plus 4 times. So height is given as 6. So half into height is 6 and base is 4. So we will get 16 plus 48, which is 64. Again, like if we are not able to observe that we have a square and we have a triangles, we can do this manipulation. So this was there in one of the websites. So what they're doing is, suppose you have this pyramid first. So from here they will open up the sides like this. from the top they are opening up, like you peel the banana, so they will open it like this. So you have this base square, and then they will rotate it. Okay, then they will rotate it. From there, what they will do is they are rearranging it. For example, if you have this triangle here, we have the same triangle here as well, and this triangle they are inverting it and keeping it like this. Okay, everywhere they are doing same thing. These four triangles we will get from these four triangles. Okay, from here what they'll do is they are moving this triangle and keeping on the right side, so you will get a rectangle like this. So you will get a rectangle like this. So once you get a rectangle and a square, it's like very easy to calculate the area. So you have this as 6, this as 2, because this is the midpoint here, and this area is 16. So 6 into 2 times 4 times plus this area square, which is 64. Okay, so again 6 into 2, which is 12, times 4, which is 48, plus 16. Okay, now we'll write down a couple of formulas which are needed for this one to solve the rest of the problems. So first one is the surface area of cube. This one is like very simple. Everyone knows this. So cube is made up of 6 squares. You can see here we have one here, one on the left, one on the right, one on the back, one on the front, and one downside. So each of them is a square. So area of the square is a square. We have 6 of them. So 6a square is the surface area of the cube. What next? Surface area of a rectangular prism. So this side length is missing here. So I'll put this as A. So what is the surface area of a rectangular prism? So if you can see here, this area and this area, they have same areas, correct? So it will be AB plus AB. Similarly, if you see the rightmost side and the leftmost side, consider this as a box. Even they have same area. We have BC plus BC. Now, if you check this back side and this front side, so this height is C, even this height will be C. So we have AC plus AC. So 2 times AB plus BC plus CA. So this is the formula for surface area for rectangular prism. Anyways, again, straightforward observation. So we'll move on to the next one. Surface area of a triangular prism. Surface area of a triangular prism. What could be surface area of a triangular prism? Yeah, very good. Yes. Surface area of a triangular prism, all that we have is let's assume that this is an equilateral triangle because only one side is given here. So I'll assume that this is an equilateral triangle here. So we have 2 triangles. So area of those 2 triangles will be 2 times root 3 by 4 a square. Plus then we have 3 rectangles. Imagine this is a 3D figure. So we have one rectangle here. Okay. And one rectangle here, which is in the front side, and one on the left side. Consider this to be a 3D figure. So we will have 3 times area of rectangle is a into h. So we will have root 3 by 2 a square plus 3h. So this is the area of a surface area of a triangular prism. Okay. We'll see one more thing. Surface area of a right prism. Surface area of a right prism. How to get the surface area of a right prism? So if you have doubts in this is the formula. Okay, so we'll move on to next question. So in this case, S is the surface area of the base. Is it the surface area? I think we need one more factor here. Okay, assume that this S is this perimeter. Okay, assume that this S is perimeter. So what is a right prism? Right prism, see, generally, if you consider this one, there is an, what can I say? There could be like prisms, like, see, best example I can give you is a cylinder. Okay, cylinder is a right prism with a circular base. Correct. Now, if the base and the height are at 90 degree, they are called circular prism. But the base need not be a sorry, they are called right prism. But base need not be circular one. So we can have the similar bases on top and bottom. Now, if you connect each and every point, they are called right circular prism or right prism. Okay, if the base is circular, they are called right circular prism or cylinder. Okay. Okay. Now, S I took it as this circumference. So, what is the surface area? Yeah. If this is hollow, surface area will be S into H. Okay. I'm assuming that this is a hollow thing. I mean, I am not considering this area. Oh no, I'm just considering curved surface area because nothing is given about area of this one, and all that they have given is this entire length is S. So if this perimeter surface perimeter is given, then area will be S into H. Okay, you need not worry why this is S into H. We will prove this later. If not in 10th, we'll prove it in 11th standard. And that time, maybe using integration or maybe using some other techniques, we'll prove that it is S into H. Okay. Surface area of cylinder. Surface area of cylinder. What is the surface area of cylinder? Assume that it is a, there are bases also. Okay. Including bases. Yeah. Now, if you consider this cylinder, you have two bases with the radii r. So area of bases will be 2 times pi r square. Correct? 2 times pi r square. This is area of base. So this area of curved surface will be, if you open up the cylinder, you will get a rectangle. Correct? You will get a rectangle with height h, with height h. Now, if you open up this, what is this length? This entire length. What is this length? 2 pi r. Yes, very good. This length is 2 pi r. You're opening up. So you will get this as 2 pi r and this as h. So what is the curved surface area? 2 pi r, length into breadth, which is 2 pi r h. Now we need to add these two to get the total area, which is nothing but 2 pi r square plus 2 pi r h. So we will get 2 pi r into r plus h. Is this clear? This problem, or rather this formula? It's clear? Okay, we'll check two more and after that we'll stop for the day. Surface area of a sphere. Ketan is asking how to prove surface area for a sphere. Integration. We need integration for that. 4 pi r square, yeah. Surface area for the sphere is 4 pi r square. We will take it for granted now. Later we can prove this using double integration. We'll learn this in first view, don't worry. Okay. So this is very much needed for JEE. And I think it's there in PU syllabus also, double integration. Okay, 4 pi r square. one thing that you might have to observe is surface area of a sphere with radius r is same as surface area of a plane circle with radius 2r. Correct? Surface area of a plane circle. If radius is 2r, surface area is pi r square, which is pi into 2r square, which is 4 pi r square. So if you have a circle with radius 2r and if you have a sphere with radius r, their surface areas will be same. Okay, in one case it is just a flat circle with radius 2r, and in other case it's a sphere. Okay, one last thing, surface area of a cone. Surface area of a cone. Including base. Including base. Okay, I'll give this as homework. Like I want to derive this actually, so we do not have time now. But what you can do is you have this much input. Like you have radius as r. This is the slant height L. This is the edge. First, figure out what is the relationship between L, H, and R. And they have also given this curve surface to be this perimeter to be C. Now get me a nice formula for surface area of cone. Okay, he's saying pi r into r plus L. Okay, let's discuss this in tomorrow's class. Okay, and I'd like to give a couple of problem. I'll give one problem. Rest of the problems I'll discuss in my class. Which one I want to give? Okay, this problem. Note down this problem. This is your homework. You need to answer me tomorrow. In a spherical ball, a large number of dimples have been carved. Okay, so there are inside projections. The shape of these dimples is a part of a sphere. Okay, so each of this, if you take this small, this one, this is actually a part of a bigger sphere. If you take this and you can make a bigger sphere using this smaller one. So basically our end material, they have taken one sphere, they have cut it and they have put it here inside that. Okay, now is it possible for the dimple ball to have a smaller surface area than it had before the dimples were carved? Okay, initially there were no dimples like this. It was like a proper sphere. Now they have made dimples. Now they are asking, is it possible for this sphere to have smaller surface area compared to the original sphere? Yeah. So this is your question. One is to get the surface area of a cone, and one more is this dimples. Okay. Anything else is there? Okay, this we'll see next class. Okay. So get me the answer for this class. Okay. Next class is maybe on Monday or Tuesday, I guess. So whenever there's a class, we'll discuss this. People are saying its surface area will increase after dimpling. Yeah, I wanted to know whether that is the case every time. Like, what if I create a bigger dimple, or what if I create a smaller dimple? Just think about it. So everyone is saying I can have a larger surface area but not smaller. Okay, just think about it and we'll discuss in the next class. Okay. Thank you. Thank you, everyone. See you next class. Bye bye. Yes, Ricky, we can have smaller, but when can we have smaller? We'll discuss this in the next class. Okay. Chalo. Bye bye.